As we go on to section 2 of chapter 5, we want to do a little vocabulary building. When we see the word polynomial, poly is the prefix for many numbers. One of the subcategories is when there's only one term, we get mono, two terms, bi, three terms, tri. So these are sometimes used, but all of these are considered polynomials. And also in the real definition of polynomial, we don't come across it much in our book, but for instance, if you had a term like a to the second over b to the third, when you have a variable in the denominator, that's not considered a polynomial. It's kind of a technical definition. Another definition you sometimes say is if you have a term, let's say b to the negative 2 power. If you have any variable with a negative exponent, that's not considered a polynomial. That's if you're being really technical. Now, for degree of a term, and we'll see that down below here, what we do is we add up, let's do this one right here. The degree of a term is the sum of the exponents within a term. So here the degree of this term, remember terms are separated by either plus or minus, this would be 2. Here the degree of this is 1. The degree of this is 0. Here this is 1. This is 0. Now here there's just one term, but the degree of this one term is the sum of the exponents. And keep in mind there's a 3, a 2, and a 1, so the degree of this term is 6. This one is 5, and this one is 0. So I've placed the degree of the terms under the terms in the expression. Now, what is the degree then of this expression? Well, the rule for the degree of the expression is the largest degree of any one term. So for this, the degree of the expression would be 2. The degree of this expression is 1. The degree of this is 6. And the degree of this is 5. Now keep in mind this is a trinomial with 3 terms, a binomial, a monomial, a binomial. But remember, they're all polynomials. Let's go on. Now in this example, they want you to identify the degree of the terms and the degree of the polynomial. So let's do it together. This is 2. This is 1. This is 2. Remember, there are ones when there isn't an exponent written. This is 3. This is 1. This is 0. This is 4. This is 4. This is 4. This is 7. This is 5. And this is 2. So those are the degrees of the individual terms. Now, what's the degree of the expression? And the rule is the highest degree of any one term. Well, this one is 2. This one is 3. These are the degree of the expression now. And this one is 4. And this one is 7. Now, many students get this mixed up because they'll then add them all together, and that's not what you do. The rule is the degree of the expression is the highest degree of any one term, and the degree of a term is you add up the exponents only on the variable in the term. All right, let's go on to part 2. Now, we did some of these back in chapter 1, where we're going to put in a replacement value for the variable and then calculate what it would be. But this is in function notation. So when the variable is 0, 4 times, let's say like this, you could do it like this. When the variable is 0, 4 times 0 is 0, this is going to be a negative 7. When it's a negative 2, 4 times negative 2 is a negative 8, and a negative 7 is a negative 15. Okay, following this pattern, let's see what you can come up with. And we'll pause. Okay, you can check your work here. Again, they're looking for a pattern, a methodology of substituting in your variable using parentheses, and then step by step arriving at your answer. If anyone has a question, of course. Now, as we look at example 3 here, keep in mind we just want to combine the numerical coefficient when we're adding or subtracting, that is, combining like terms. So this is just going to be a negative 7x. Now, a strategy for something like this might be to put your like terms, as we mentioned before, in vertical like term columns. And copy them down correctly here. So when they are in like term columns, you can easily calculate. Remember, when you're adding and subtracting, the variable never changes. And then here, we'll just set it up. So lining them up in like term columns, then you have a clear way to kind of check your work, and lining them up hopefully increases accuracy. Now, if you want to do it horizontally, that's an acceptable way as well. But I think this is to get that accuracy. I've seen people mess up on this. All right. Strategy for this one. Here they're asking you to add. So just put them in like term columns. And we'll add those up. Now here we're going to write the top out. Now when there's a negative sign in front of the parentheses, it changes these signs to their opposite sign. So the opposite of a negative, change both of the signs. So this now is a 5x here plus 3. So when you add these up, you'll get the right answer. Now here's something that students have had problems with, where it says to subtract this. Well, think of having a negative sign in front of the parenthesis. So we can write this on top. Now subtract this, change both of the signs. Change this one, change that one. Now you just add them up. And on your tests, should you get one like this, again, there's 20 questions on Chapter 5's test. Just getting one wrong, that really hurts. Again, you want a technique so that you get the correct answers. Here, I'd put a little star by that to watch the wording. Subtract something. Change the signs and then add both of them. Okay, short lesson.